Hi, welcome to the assessment number 2 that we have did on the unit DENG604, that is Engineering Practice and Key Research Methodologies. So for this, we have done an experiment to uh, devise an obstacle detection device by measuring sound signal. So the outline of my presentation is introduction, methodology that is employed, analysis of the sound signal, then result and conclusion, and then references. So for the introduction, basically the sounds are a form of energy which are always in vibration, and the sound can be categorized into two types, that is longitudinal and transverse waves. Human ear basically are capable of hearing only limited frequency, that is from 20 hertz to 20,000 hertz. The scope of experiment right now is to design an obstacle detection device using sound signal. So there is a requirement for the software to record the sound signal. So basically for this we have used an Audacity app, which is freely available in the net for the recording of the software. Sound generation needs to be done in different frequencies, and for that we have used a mobile uh, to generate a sound, and we have used an online tone generator. So the methodology employed here is we have used a laptop to record the signals. Then we have used uh, mobile handset to generate a sound, and then in between we have kept a door to open and close so that we record a sound when it is open and when it is closed. Then the signals were captured in the laptop and then it's analyzed. So the analysis of the sound, it is done in different ways. Number one is removal of noise. For the signal in time domain as well as in the frequency domain, we have just shown here for the 500 hertz signals, but it is not apparent the differences over here because we are not able to see a lot of differences in the removal of the noises to the signals. Obviously, there are not marked differences, but the differences can be seen in the time domain, smoothing of the signal, and in the frequency domain, the area that is basically an energy is reduced for the signal which is used for recording with the closed door. The open and closed door detection basically is done by opening and closing of the door, and the signal shown over here, we can see that the amplitude is reduced for the closed door, and the area which is energy is reduced for the closed door in frequency domain. And for the purpose of comparison here, we have used 3000 hertz and 1500 hertz for the comparison. So we have also calculated the accuracy in the data, and for the calculation the accuracy, it can be known through the calculation of percentage error, which is basically experimental value minus expected value divided by expected value into 100. So here we have taken out 4 samples, and those samples the sound intensity is actually compared, or percentage error is calculated based on some kind of expected value, which is kept as arbitrary here as negative 46 dB. So from this we can see that the percentage error for different samples varied from almost 0 to 51 or 56, because this percentage error is more because we have used in at the initial to record without any sound signal, so that we can use it for the removal of the noise. So the accuracy can be positive or negative depending on the value, which is over and below the arbitrary expected value. So we have ultimately done this experiment also to plot a probability distribution curve. Here, four samples were taken for the 1500 hertz, and we can see that the yellow light, the distribution sample 4, is having more accurate or more probability, better probability than others. Here we have used Excel, Microsoft Excel, to plot, do the analysis for the probability distribution curve. And result and conclusion. If you can see that both time and frequency domain signals, it showed more intensity and energy for the open door than the closed door. And from the above sound experiment, we can also see that the total energy content in the frequency plot is more in open door than the closed door, and indicates the frequency components between 3000 hertz to 7000 hertz in open door, which is not present in the closed door. So these can be used for configuration of the obstruction detection. So with a hypothetical reference value of negative 46 dB, we can also see that accuracy of the sample in table given at figure number 4, figure number 3 above. So the probability distribution curve for the 4 sets of samples taken for 1500 Hz frequency shows the sound intensity of 46.3 as the most probable intensity of the sound signal, and intensity of the sound varied from 40 dB to 51.7 dB. So with this, I have the list of references over here, and thank you so much.